Good morning, everybody. That's the webinar number 17, and we will talk about the role of bugs in software development process in general. First of all, I'll try to show what is the typical traditional understanding of bugs, of their roles in any software project, and then I will demonstrate what are the typical mistakes people do in that understanding, and then in the end I'll become a little bit more philosophical, and we will discuss in general the role of bugs and what their role is from a bit higher perspective. So first of all, a few words about what these bugs are and how we traditionally understand them. Most teams, most testers, that's my experience, that's what I've heard many times, they think that testing and the process of finding bugs and the QA process, which is usually this testing is called, which I think is not actually right. People believe that bug or a defect or a mistake, it's something which we are trying to fight against in any software project, and which is something which the bug is something that we have to avoid at all costs, and this is something which is really bad and something which we are trying to not to make visible and not to make seen. So that's why the testing process is taken as an activity with the goal of proving that the software doesn't have bugs. So that's what most of the testers, which I know, believe they're doing. So they are looking at the software, trying to break the software, trying to test it somehow, running some tools on that, doing some experiments with the software in order to prove that that piece of software, that particular package, is actually good enough to be released. So the role of the tester is, that's what people believe, is that the role of the tester is to demonstrate that there are no bugs in the product. And then if there are no bugs, if there are some bugs, then the tester actually reports that bugs, and then programmers fix them, and then they come back to the tester, and the tester retests again. Sometimes it's called regression testing. So these testers, they retest again, and then they are still trying to say that the product is ready. It's good enough for the release. So it's good enough for, and that means that they understand, everybody, not just the tester, but everybody around the tester, understand that the bug is something which is bad. We don't want to see it. We don't want to know about these bugs. We are trying to lower the amount of them. So the less bugs we see, the better for everybody. This is obvious in this approach, because the tester, every time the tester returns back the product to developers, it's kind of annoying, and developers are not really interested to see that bug's coming back, because it delays the whole process and it makes the delivery slower, and the time of release is getting pushed back and back. So in that case, bugs is something that every bug is something which is treated as a bad thing in a software project, and then that's a traditional understanding, and most of the tools and most of the methods of testing are kind of traditionally oriented towards that direction. So they are all about trying to prove that that software is good enough for the market, is good enough for some quality criteria. And this is wrong. This is what, like, many books are saying this is wrong, and many articles are written about that. I'm not the first one who is saying that, but still, like, not every second, like 90% of testers I know, they believe this is their role, to prove that the product is good enough, to validate the product, to test it and say it is good. That's what they think is their role. And that's really wrong, and that's what I'm trying to show. So the right approach, the right strategy, the right point of view the tester should have is that the role of testing is actually to prove, and not to prove. The role of testing is actually to, well, we can say it that way. The role of tester is to prove that the product is broken. But it's not just to prove that it's broken, but actually the role of tester, and I'll explain it now why, the role of tester is just to find as many possible bugs, as many bugs as it's possible to find in certain amount of time or within certain amount of budget. So the tester is not the person who is proving anything or unproving anything or saying the product is good or saying the product is bad. The tester is just looking at the software package and tries to break it as much as possible from all the different angles, from all the different perspectives, and reports these bugs and gives these bugs to programmers. And then programmers make, not just programmers, but managers and architects, whatever, people who are like looking at this product, they are making the decision whether having in mind this amount of bugs being found and reported, whether this product is good enough for the market or not. So the role of the tester is not to say good or bad, is not to stop the delivery, is not to block the delivery, but actually to break the product from all the different angles and then report that bugs. And the overall role of not the testing, but not the tester, but the testing process in general, is actually to show us how many of the bugs which are in the product anyway we managed to find. So the theory is that there, in any product, in any software package, there's unlimited amount of bugs. So no matter how simple it is, no matter how well tested it is, no matter how complicated is the software, or no matter what languages is used, it doesn't matter. Any software package, because the complexity is so high, any software package contains unlimited amount of bugs. The question is how many of them we already managed to find, and how many of them are still there, hidden, not found yet, and yet to be found. So that's the definition of software quality, which, I mean, most people don't probably understand or maybe don't agree with, but this is really true, and I believe in it. So any product, again, has an unlimited amount of bugs. It's just a question of how many bugs are already reported, and we have it in a bug tracking system, and how many of them are still there and yet to be found. So let's say, imagine we're developing that product, and we are right before the moment of putting our first version to the market and releasing it to the market, to our users. And now the question, for example, for me being a manager of this process, I would say, how can I be sure that this is the right moment of time to actually put the product on the market, and maybe I need to delay it for a week or a month? So how do I make this decision? So the right approach is to have in mind, first of all, but that we cannot make the product bug-free ever. This is just theoretically and practically not possible. No matter how long we work on it, it's still going to contain unlimited amount of bugs. Not many bugs, not some bugs, but unlimited amounts. So it's not possible technically and theoretically to reach the moment where we can say that like most of the bugs are fixed or all bugs are fixed. So the bug-free delivering the product to the market, which is bug-free, it's a myth, it's a misconception. If any of you or any testers you work with or any managers you work with believe in that, and they're saying to you that we can only release when it's bug-free, or they're claiming that we are aiming our quality system to only deliver bug-free products, they're just lying to themselves and to yourself. It cannot happen, and it's just wrong conceptually. They don't understand the concept of testing. So that there's always unlimited amount of bugs. The question is, how many of these bugs will be found by our users, and how many of them will be found by our testers? So that's the only question we have. Because we want these bugs to be found, we want more bugs to be found by testers than the amount of bugs will be found by users. That's it. That's the only thing we can do. Because still, some bugs will be found by users, or maybe very few of them will be found by users. But it's not possible to say that none of them will be. Well, we can aim, we can put that goal in our quality system that we want 0 bugs to be found by users. This is an achievable goal, more or less. Depends on the amount of users you have, because if you have millions of them, it's really probably hard to achieve that, because still some of the bugs will be difficult to find in a laboratory in testing, and they will go through our release border, and they will go to the market, and then the market will find them. But we can aim for that. We can say we want our testing to be as good that none of the bugs will be none of the bugs will be found by the user. So we are delivering the product which is not bug free. Absolutely, it's full of bugs, but all these bugs are so minor and so small and so difficult to find that none of our users can actually manage to find them. So we're getting 0 reports from our users. This is an achievable goal. So that's what we're working on. That's what the testing processes probably should be aiming for. But in order to do that, we need to understand that the bugs which we're finding here locally before the release process is actually every single bug we're finding here during the development process is decreasing the chances for that same bug to be found by the market. Actually, not just decreasing the chances, but completely, or maybe not completely, yeah, decreasing the chances. That's right, because we don't know whether this bug will be fixed entirely. Maybe it will be just half fixed or just will disappear for certain reasons. So the point is that we need to aim for finding as many bugs as possible. In that case, we'll lower the probability of these bugs being found by the market. So the testing has to have that in mind and always aim for just finding as many bugs as possible. Not confirming that the product is ready, because they cannot confirm. They can only confirm that we cannot find any more bugs. That's what they can claim and say, we just done some testing for 2-3 hours or 2-3 months, I don't know, and we can't find anything else. We just stop testing because we are not capable of finding more. That's possible to say, but they shouldn't say there are no more bugs, because we understand there is an unlimited amount of them there. So when the tester says the product is good, it means that the tester says, I can't find any more bugs. Why the tester can't find any more bugs? There could be a number of reasons. The reason number one, the tester is lazy. The tester just saying, yeah, it's good enough. I download the app, I click a few buttons, it works. I don't want to do any work anymore. So I'm just lazy enough to find more, and I'm saying the product is good. That's the first obvious reason. The second reason, the tester may say, the tester may be just incompetent. So the tester is not lazy, the tester is trying, but the bugs are so difficult to find that the tester has no competence to do that. For example, these bugs show up only on the high load. So the tester doesn't know how to put a high load on our app or on a server. So the tester says, it works all right, which means that it will fail on the high load. It will fail on the stress, but the tester doesn't know how to put that stress over there. So the tester says there are no bugs. Maybe the tester, the number 3 reason is probably the tester may say that, can say there are no more bugs, which means that the tester doesn't have any more time. So the tester just got 1 day, for example, and then by the end of the day, the tester says, there are no more bugs I can find because my work day is over. So nothing else can be found because time is over. Or it could be like the tester says, you're paying me for, you paid me a certain amount of money and this money is ran away. I don't have any more budget. So that's why no more bugs for you guys. So there could be other reasons as well. So there are many reasons for that, but every time the tester says there are no more bugs, or that actually means technically that just testing is stopped. The testing process just was finished. It doesn't mean there are no more bugs. It means we finished testing. Why we finished testing, it's another question. Like I said, it could be like we're just lazy, we want to go home, or we don't have any more money, or we just don't have any more tools, or something like that. But the testing is over. That's the only statement which is logical in this case. The testing is over. And now we're getting to the most interesting question. So how we as managers, what's the good time for us to actually believe in that statement? So how do we know when the testing is actually over? What's the good moment for us to say, all right, yeah, you're saying the testing is over, I trust you, the testing is over. So when the tester says the testing is done, it doesn't mean that the manager will actually agree with that and say, yes, the testing is done, we're ready to go to the market, we're ready to release that version of the product. And that's a really interesting question, because how do we know that the tester found enough that when we put it to the market, we will not get back bug reports from our users the next day? So how do we know that all the critical and all the visible bugs are, or the majority of them, are actually already in our bug tracking system, and our customers will not find more, or it will take so much time for them to find that when they find them, probably the new version will be on the market. There are a number of approaches, and some of them are, like most of them or all of them except one, I think, are wrong. So the first approach is, let's say we have, first of all, is the time is over. We were planning to test for a month, or we're planning to test for a week, and then the week is over. That's it. We stop testing. We fix everything which was found, and then we put it to the market. That's why it's wrong, because there is no. I don't see any logic in this approach. So I don't understand why 1 week is enough if there's a limited amount of bugs and we just found a certain amount of them. How do we know that testers were not like, sitting and doing nothing and telling us that, yeah, there's 50 bugs we found, that's it. Maybe there are 500 more. So we don't know. So there's time limitation, time boxing. I think it doesn't have any reason behind that. The second approach is money. So we can say we hire some tester or some company which will test for us, and we pay them a few $1,000s or a few $1 million, and they test our product using this amount of money. Probably they will, not probably, but certainly they will use this amount of money to pay salaries of testers. And then when the money were spent, all of them, then this company will say, yeah, we are done, the testing is done. Again, I don't see a lot of reason behind that, because how do we know how effectively that money was spent? How do we know that these people actually managed to find that critical bugs which are still there, which are still in the product? So how can we control that? No matter what they promise, no matter what they say, yeah, we're using the best tools on the market, our testers are so professional, but still it's unmanageable, because we just paying for, we don't know what we are getting back. We don't know how many we have left. So it's, again, I don't see any reason, any logic behind that. There's another approach which is called regression testing, which I think is even worse than the previous two. Is that people are saying we have a number of test cases. So we have just a test plan, so-called, and this test plan contains test cases or test suites, and test procedures or test scenarios, and there's a long list of them. And every time we want to test our product, we just give this list, give this documentation to the tester, and the tester goes through all of them one by one and makes sure that all of them work. So the tester actually downloads an app, clicks a few buttons, does certain procedures, and makes sure that all of these procedures are being executed again and again every time we trying to put the product on the market. This regression test, well, first of all, it's kind of strange that that some people are still using this approaches when if this logic, if these scenarios are so predictable and we know exactly what needs to be done, then why can't we just automate it? What's the point of using people and testers for that? Because all of these tests, they have to be like just part of the build, so they have to be executed automatically. But let's say some of them cannot be executed automatically, and you still need this regression testing. In this case, we definitely can use the regression testing. It's a good approach to find the really critical and fatal bugs, which are breaking the core functionality of our product. But this regression test and its results cannot be used as a signal for us, as an indicator for us that we've done the testing and we are ready to go to the market. Because if this regression test produces 0 bugs, the only information for us is that the regression testing is bad. So this regression testing is not sufficient enough, is not strong enough to find new bugs. So if no bugs are found. So if the regression test found nothing, it means that we just wasted basically our time to validate the functionality, to go through the functionality, but we didn't manage to find any bugs, which are definitely there. So we know that the bugs are there, and then we run this regression test. We spend 5 days on that, and people are working and doing these monkey jobs by going through all the features again and again, and nothing. And in the end, we have 0 bug reports, which means we wasted the whole, this 5 days period. We wasted our time. We didn't find the bugs which are sitting there. So this is we just basically we didn't find bugs, which means that which is an indicator for us that that the functionality works. Well, works not works 100%. It's still broken somewhere and somehow, but at least it's not more broken than it was before. But that's just the the basic level of testing. It doesn't really help us to achieve the main goal, which is, like we discussed before, the main goal is that the market sees less bugs than we can see here. So we always want our market, our users, to find less bugs than that we manage to find. And this regression test doesn't help us at all, because we find 0 bugs basically. And the goal of this, and in most cases the testers, this regression testing kind of motivates testers to find 0 bugs, because when you go through this test plan, and you look at these test cases one by one, usually it's like a piece of paper where all these test cases are numbered, and in next to each test case there is a checkbox which the tester is supposed to mark as a with the green color and saying done, done, done. So this saying done when actually there are no bugs, it turns the philosophy, the mindset of a tester upside down. So the tester thinks that for him or for her, done means no bugs. So the test case is passed. The test case has been, has passed, and there are no bugs discovered. And it has to be the red sign. It has to be not done. It has to be failed. So we just failed to find any bugs using this test case. So we were using the tool which is supposed to help us to find bugs, and this tool didn't work. So we tried this functionality. We tried to click this, button by button, and do something with our application or our web system. But in order to find more bugs, well, we didn't manage to find. That means we're not done. It means we failed. The test case has been failed by us, by the tester, and it failed by itself. So it's bad, probably. It's not powerful enough to help us find bugs. But traditionally, usually the testers, they use the green color to mark all these test cases, these checkboxes, and they're saying done, 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 and then they're happy coming back to the project manager and saying, I'm done. All the tests are passing, and they're showing this report, this checklist, and all the checklist is all green, and it says, good, great, thank you very much. But it shouldn't be like that. It should be the red color. It should be done like I failed all of them. I didn't manage to find any bugs. That will be the good information for the manager. So my point is that the regression testing is not really a good, even quite bad strategy to use in order to decide what's the good moment to put the product on the market. And there could be, I don't know, I haven't seen many more like other alternatives, how we can decide when it's a good time to, how can we decide when it's a good time to stop testing? That's the main question. It's called test exit criteria. So what is the exit criteria? So when it's time to exit testing process, when it's time to stop. And there are many like possible answers, like I just given you 3, and maybe we can find more, but I think all of them are wrong, except one. And this one is, it says that we need to use the number of bugs found as an indicator of success or failure. So when we start testing, we don't know how many bugs are there. There's unlimited amount of bugs, but we have some previous history. So we know that, for example, our team of programmers from the previous projects, we know that they are, we created a product and then we put it on the market, and then within 5 days, we got like 50 bug reports from the market. So we can say probably potential. We can predict that if on the next release day, on the next release version, we find 50 bugs, and then we put the product on the market, then it seems to me that the probability that the market will come back with another 50 bugs, it's quite low. So we think that if in the previous version just 50 was found, and let's say we fixed them that 50, and the users became happy, that's probably in this version, our programmers, using their knowledge, their skills, their abilities, they will probably deliver the product which also contains 50 obvious bugs, 50 bugs which are easy to find for our regular user. So that gives us a prediction, that some number to predict, which is 50, number 50. So when we ask testers, we're telling them that you guys have time or money, it doesn't matter. You give us the numbers, you estimate that, but we need 50 bugs. We need 50 bugs to be found, and I'm talking about critical bugs or major bugs, and that bugs need to be found before we can say that the product is, and then we will fix them, of course, and then we will say that the product is ready for the market. So that's the goal, that's the good exit criteria for testing. When 50 bugs are there, when we have these 50 bugs in front of us, and all of these bugs are approved, means that they are approved by management or by programmers and or the architect, and they said, yes, these bugs are valid, thanks for finding them, we have them in our bug tracking system, we will fix them. At that moment of time, we can say, yes, our testing is done, and we can finish fixing these 50 bugs, and then we go to the market. On the next version, we will see the reaction of the market. We see what's going on. We will look at how many bugs we actually deliver to our users, because they will come back and say, you still have some problems. Maybe they will come back with 100 bugs. I don't know, maybe with 10 of them. So they will give us some number back. And we can use this number to continue our prediction process. So we will look again how many, lines of code or features, or how many changes we've made to the code, so that it jumped from 50 bugs before to, let's say, the market gave us back 100. So it means we had 50 bugs on the first version, and then on the second version we found 50 bugs in here, we fixed them, and then the market gave us back another 100. So it looks like we had 150 visible bugs, and 10 of them, like 70% of them, went to the market. When 50 bugs were found here. So it looks like then we need to compare version number 1 and version number 2 and see how many changes were done, who were the programmers who worked on that piece of software. So what was different? Like why did the amount of bugs jump from 50 to 150? And then we make another prediction for the next version. We say, okay, in this version, probably the amount of bugs will be 200 or 250. Or we have so much money and time that let's aim for 500. Let's ask our testers that we need 500 bugs now. Do whatever you want, use all the tools, use the money, use the budget, use your time, but we need 500 bugs. Because we predict that 50, 150, maybe it will jump even higher. So to prevent that bugs to enter the market, we need the 500 to be reported. And then the goal of these testers, their objective, their primary objective, will be not to run the regression test, not to run some test cases, not to spend certain amount of time, not to spend certain amount of budget, but to deliver us 500 bugs. It's not really easy to find a tester who will commit to that goal. Because traditionally, when you go to testers or you try to recruit a testing company, try it yourself, any company you talk to and you come to them and say, we need 500 bugs, they will say it's not possible to predict like that. We can't guarantee you that. We can guarantee you that we're going to spend 500 hours on your work, on your job, on your project. But we don't know how many bugs are there. We cannot guarantee you 500 bugs. And that means that they are not understanding what the testing is. That means they don't know what they're doing. That means that they are just, selling you their work time. They're just selling you the time of people sitting in front of their computers and doing some work. But they have to work, like I'm saying. They have to promise you, not just companies, but also testers in the office. They have to promise you numbers, which are number of bugs they can find. How they do it is their job. They have skills, they have tools, they have time, they have money, coffee, whatever. They have computers. So they use it all together. They put it together in order to give you that number. They give us, programmers and project managers, to give the amount of bugs. That's the right strategy. In this case, the whole process becomes manageable because we know the number. We can manage numbers. We know that, like I said, like in this calculation, we know how many bugs we're getting from the market. We can compare that number with the number we're getting locally, and we put these two numbers together, and we analyze the past, and we predict the future. We predict the future. We maybe double this future. We maybe multiply it by 5, 10, depends on our time and money situation, and then we find more and more bugs. So everything, all the testers have to be pointed to one direction. Find a certain amount of bugs or as many bugs as possible. But as many bugs as possible is not really a good goal, so I would not use that. I would try always to number them, to calculate them, and point and put the strategy in place, which always says that we have a plan for bugs. We are planning our bugs. We are planning certain amount of bugs to be delivered. We want our testers to deliver us bugs. So it may sound controversial, it may sound not really usual, but this is the goal of testing. This is how it should be planned. We plan bugs. We want that bugs to be reported. Bugs is not something which is we don't want to see. This is something we want to be reported. And now I'm finishing. I want to give them summarize that and give a more philosophical view, not philosophical but more conceptual. I think that finding bugs and testing software has to be the same process as writing code. They have to go in parallel. So it's not like programming first and testing second and then the delivery. They should go in parallel. They are two parallel, equal to each other, equally important processes. One process, one track is writing code and delivering code, making commits to your repository. And the second process, the second track, which goes in parallel, which is also as well as important as the first one, is delivering bugs. Finding and delivering. Delivering means going to the bug tracking system and reporting them. Reporting. If I'm the developer, my job is to deliver you Java code. If I'm the tester, my job is to deliver you bugs. And then the question is how well the second track is organized and controlled and motivated and paid. So it has to be, as far as I understand, it has to be managed and organized in a way as any process which delivers some tangible things. Anything that delivers, for example, I don't know, like I'm writing code. So I'm writing, I deliver, and you say, yes, this feature is delivered, that one is delivered, this piece of code is committed. You check my code, you check the quality of my code, you do code reviews, you do you overview the code, you control, you pay me for my results, you pay me in an ideal situation, you pay me for the features I delivered. The same should happen for testers. The same should happen for testers. We need to know how we plan this process. We need to know how this testing is planned. So how many bugs we plan to be delivered, where these bugs are reported, who is available, who has the permissions to report it, what are the priorities and severities, priority, severity, all the indicators of every bug, how they have to be explained. So we need to plan it in advance. Then we need to plan how we're going to control that. Like how this tester is going to come back and report their process. It's not going to be just the process of testing. They need to know how they're controlled. We need to know how the quality is controlled. So we need to control the quality of bugs. I'll say it again. Bugs, they have quality. We have low quality bugs and we have high quality bugs. One bug is reported properly. It was found. It's reported properly. It's properly like the description is proper. The title is proper. All the screenshots are attached. This is a high quality bug, and we have low quality bug. When there's nothing is properly explained, the bug says like the application doesn't work. Period. This is a low quality bug. So someone or somebody or many people maybe should control the quality of testers. So when testers deliver something, we need to control them and make sure that they deliver high quality bugs. How many of you have heard about that before? I don't think many, because I haven't seen like too many. I haven't seen companies which are doing actually this quality control of testing. Well, we need to do it. We need to know how do we pay them. We need to understand how these testers are being paid and motivated. So in my opinion, they have to be the ideal approach is to motivate them by the amount of bugs they find. So for every bug the tester brings to the bug tracking system, the tester gets some money. In that case, I think this is the clearest, the easiest, the simplest, and the most straightforward motivation strategy. Certain amount of money for each bug found. No bugs, no money. If there's no bugs, then you don't know what you're doing. You don't deliver us anything. It's like with the programmer. If programmer doesn't deliver features, doesn't fix bugs, doesn't implement anything, we shouldn't pay the programmer because there's nothing delivered. Well, unless the programmer is doing some high-level research of something, but that's a different story. I'm talking about commodity programmers. And I'm talking about commodity testers here, like testers who are doing routine testing. It doesn't mean that this testing is boring and not interesting, but this is the testing of something which needs to be tested. There's no no so much room for creativity and thinking for days and months. So the tester has to deliver bugs, has to be able to report them, has to do it high quality on a high quality level, and we have to pay the tester for the amount of bugs that tester reported. That's, in my opinion, the easiest, the most straightforward way to motivate testers. And then we need to think about how we basically that's it. Probably we need to know how to plan, how to control quality, how to pay, how to motivate. So this whole track of testing has to be managed like the track of programming. They're both working in parallel. Programmers deliver code, testers deliver bugs. So bugs is the deliverable. Each bug, or a stream of bugs, or a flow of bugs, all of them, they have to be delivered, organized, and we have to pay a lot of attention at how we do that, how we manage this bug delivery, how we report them, how we control it, how we go through all this listing and remove duplicates. So in ideal situation, we need some quality control people who would go through the bug tracking system and see duplicates and remove them and notify people that you should pay more attention when you deliver duplicates. We need to probably make some comments on certain bugs, explaining what's wrong with that, explaining why this particular bug is of low quality and that one is of high quality. So it has to be done. It has to be managed. And then we will be good. If we put the philosophy in place that testing is for, like I'm summarizing, so if the philosophy is in place and we understand that the goal of testing is actually to find bugs, not to say that there are no bugs, but to find bugs, and ideally as many as possible, and then this process has to be controlled, and the way to control it is to understand, first of all, that this is not a secondary process in software engineering. It's the same thing as delivering code. Delivering bugs and delivering codes, they go in parallel. It's like two equal tracks. And engineers and programmers or testers, they can be and should be of the same quality. If the product is high quality Java application, then the tester have to be also probably Java developers. So being a good tester is as equally difficult as being a good programmer. So testers doesn't mean that testers is somebody who's just clicking buttons. Not at all. This button clicking has to be automated. The tester is somebody who's actually able to break the software and find bugs in there. And in most cases, that the qualification, the level of that person has to be the same as the level of a person who delivered that code. That's what I believe. So now we have questions, so let me answer them. The question first, can I show more practical examples? That's a good question, but we don't have time for that. But you can check a few articles on my blog which are talking about the bugs, and you will see links to bugs which are quite good. You can look in some of our open source projects where we report bugs, and you will see like bad bugs sometimes that turn into good ones. So we're always trying to complain about bad bugs, like low quality bugs. The question is basically pay per bug found. Yes. Let me say it again. Yes, you pay for the bug found. I think this is the right motivational strategy for every testing in the world, for all testing activities. Who is not doing that doesn't understand what they're doing. So I think paying for bugs, it's so easy for testing. In programming, it's way more difficult because you cannot really in programming measure the result as easily as with the bugs. In programming, you can just say like 15 features, this is like $15 for you. Because you don't know the size of the feature. It's difficult to measure that. It's difficult to predict the actual amount of work to build the feature, because sometimes they're so huge, sometimes they're small. In bugs, they are more or less on the same level, the bugs. So you can say that yes, to find some bug which requires like load testing and stress testing, we need to spend like the whole day to build some tool which will prove that the software breaks on this particular loads or stress test. Yes, but while you're building that tool, you will find more bugs than that. You will find not just probably one bug, but more. So I'm not saying it's ideal, but I'm saying it's really better than in programming track. So in testing track to pay for results. Delivering, oh yeah, that's a comment saying delivering bug reports, not bugs. Well, probably yes. Thanks for correcting me. So yes, we're not talking about actually delivering bugs because probably the programmers deliver bugs, but we're talking about testers who deliver bug reports. So yes, their product, the final product of testers, is not actually bugs. Yeah, that's not correct, not properly said, but delivering bug reports. So testers, they have to deliver bug reports into bug tracking system. What do you define as a bug? Is it technical bug or it's some mistake in programming, so to speak? I would say that bug, that's a good question. What is a bug? I think anything that doesn't look good for a tester is a bug. It could be the tester may take a look at the documentation or a piece of code or a Java class and say, I don't understand how it works. It's not clear for me, and that's a bug. Or a tester can download an app, the mobile app, and click a few buttons and the app crashes. It's a bug. Or a tester downloads an app and starts it and doesn't understand what to click next. It's a bug. Or the tester looks at the app and there are two buttons, one is red, one is white, and the tester says, I don't like the white and the red together. It's not a good match for colors. How about you change that? It's also a bug. So anything that the tester doesn't like, which is what is the definition of a bug is its inconsistency between requirements and implementation. That's the definition given by IEEE standard. So the inconsistency between the definition, the requirement, not the definition, the requirement, and the actual product is a bug. What is that inconsistency? The standard doesn't define. So which means that anything that a tester can call an inconsistency is a bug. The next question is what bugs will be actually considered as valuable and important bugs and critical bugs by the manager, by the architect. That's a separate question. And probably for minor bugs and cosmetic bugs, testers should be paid less, and for major and for critical bugs and fatal bugs, testers should be paid more. But everything that is not good for the tester has to be reported. The tester should not worry about whether it's a minor or major or something. The tester just reports everything the tester doesn't like. That's my understanding. I think this is the right understanding. Yeah, the question is, what if they find 1,000 bugs? I'll go bankrupt. Yeah, it's a joke, but in this case, it makes sense. So you don't just hire testers and say, I'm going to pay you for all of the bugs you find, and then go ahead and find me as much as you can, because they may find 1,000 bugs if your software is, not really good enough for the market now. And this is how it should be. In the beginning, you will find more bugs and easily, and the testers will probably take a lot of money from your project. So in this case, you can put a limit and say, find as many as you possible, but the maximum is 50 a week, for example. You can find 50 bugs every week, and that's it. As soon as you find 50, you stop, and then I see what I can do. So if I have more budget, I'll give you more. If no, then thanks. Come back next week, you'll find me another 50. So you can control it in this case. You know your numbers, you know your budget, you know how much you have, and you can control the future. Another question. Yeah, I just answered it. The question is, am I talking about bugs and requirements and specifications and design? Yes, the bug is a problem, is an inconsistency in anywhere, in any artifact. The software is not just the Java code. The software is Java code and documentation and build process and logs and design and graphics and probably requirements, not probably, definitely requirements documents and design, architecture documents, diagrams, meeting minutes, recordings, some protocols, all of that has to stay in repository. All of the things I just mentioned, they have to stay in the repository. And when the tester starts testing, the tester has to look at it as a whole thing, not just the product, not just the mobile app, which is downloadable, but the tester has to look at everything and see, how is your build working? How do you deliver? How do you test? How secure is your build? Where are the logs for the build? Let me take a look at the logs. And anything which doesn't look right, the tester has all the permissions and rights and motivation to go back to the project, to the bug tracking system, and say, I don't like this, I don't like that, do something about it. The tester doesn't put any emotions in that. The tester doesn't really care what's going to happen with the bug later. The tester gets paid when the bug is reported and then walking away. So the tester is not trying to the tester should not care about what's the story or what's the history of that bug. The tester just reports the bug, and then the bugs goes to the process of the implementation of production process, and when it comes back fixed, then the tester looks at it again and says, yeah, now it's fixed, now it's better, thank you very much. And the tester closes the bug, and the implementer, the programmer, gets paid for fixing that bug. That's how it works in our process, and I think this is how it should be. One more question. Is the understanding of the domain, the problem space, could be defined as having bugs in it. Probably the question is about whether we understand properly the domain. Let me step aside and explain. So there are basically two processes which are called, which are defined, for example, not just only by CMMI, but in general by software engineering. It's called validation and verification. So verification is comparing your product with your requirements. So you have some requirements documented, and then you have a product. You compare them together and see how your actual software is different from what the paper says. This process is called verification. And during verification, this is what most testers are doing. So they compare requirements, even though if requirements are not on the paper, but still they compare expectations with the real product. So when you download a Facebook application on your phone, you have certain expectations about that application. You don't see the requirements of it. You don't know what you've never seen the document which explains how this, even though probably this document exists. Well, we as users, we never see this document, but we have certain expectations. We, for example, expect that when I scroll the app, then it's going to scroll. So it's not going to pause after every gesture of mine, and it's going to pause and wait for like 5 seconds, and then keep scrolling. So I expect that to be scrolled smoothly, and probably this is declared in the requirements document somewhere in the Facebook office. But as a tester, I compare my expectations or requirements to the real product. This is called verification. And then I report bugs. But there's also another process which is called validation. So they together called V and V. Validation and verification. Validation is comparing the needs of a customer, the real needs of a customer, with the expectations or requirements in the document. So the customer needs something for the business. And then we have a requirements document which says, for example, we have a requirements document which says the app has to be, the mobile app has to respond to every gesture in 10 milliseconds. And on 5 milliseconds, for example. So no matter what I do, that my document says, that the requirements document says that the gesture, any gesture on the mobile app has to respond in 10 milliseconds. That's reasonable, probably reasonable requirement. But then we go back to business requirements, to the situation with the business. We talk to our customer and we ask, like, do you really need 5 milliseconds? Can you explain us why do you need 5 milliseconds? And the customer says, well, actually, I don't care about 5 or 7. I just want it to be fast. And then we'll look at the real definition of fast. And we realize that fast means faster than 50 milliseconds. So the real need of the business is 50 milliseconds. But for some reason, our document says 10 milliseconds. So this inconsistency between these two numbers is a bug, which we discovered during the validation process. And also, well, maybe not a perfect example of validation, but the general validation is getting the product and moving it to the real business and seeing how this product fits into the business. But maybe it's a good example as well, yeah, with the numbers, because this is measurable. But in general, validation is take the product, bring it to the business, to the customer, try to put it there, and see what the business says about that. And if the business is happy, then the validation is failed. So the validation does not discover bugs. But ideally, the validation should happen by this, this so-called acceptance testing with the customer. So you take the product, you bring it to the customer, and you're trying to ask with customer, can you accept it? Are you happy with that? And then the customer says, yeah, this and that works all right, but here, this one, it doesn't really satisfy my needs because you probably made a mistake in defining that in your requirements document. and then you go back and you fix the requirements document. So this is done usually not by testers, but by like system analysts or people who write the requirements document. They are supposed to go back to the customer and show the customer both the product and requirements documents, and listen to the customer and get the feedback about whether the product, whether we are doing the right thing. So the validation is answering the question whether we are doing the right thing, and the verification process answers the question, do we do the right thing right? So the first question is, do these people really need what we're doing? Are we doing the right thing for them? And the second question is verification. Does this thing works? I mean, did we manage to create something that actually works? So these two processes, validation and verification. In both of them, we can find bugs. I think we need to report them in the same track. So I would say this has to be the same track, the same bug tracking system, and they all have to go in the same flow. I think so. Even though this validation and verification, they are different things in general, people like separate them. You can find them on Wikipedia. It's even the article about that called verification, validation, verification. But I think the final result of these both processes is the same. They just give you bugs which go in the same bug tracking system, and you can measure them, you can calculate them. And probably the last question. Our company doesn't have any automated testing. It's just a bunch of guys with a list of tests ticking boxes for the most part, just like I explained. We have serious problems in our company with critical bugs going to the market. Yeah, definitely. Thank you very much. I mean, I just tried to, you're not alone. You have serious problems with critical bugs going to the market because your testers are just checking boxes. They're doing just regression testing. With regression testing, you can, well, it's a few percent of the testing goal. You cannot achieve basically any good goals with just regression testing, because, like I said, the whole mindset of testers is turned upside down. They don't want to find bugs. They want to show you that they managed to pass all the regression tests. They're doing just monkey jobs. It's like clicking buttons, and their goal is to get to the end of the list. But even their goal has to be quite the opposite. They have to show everybody that it's broken. The software is broken, and that's where you celebrate. That's where you say, well, we've got a good testers. We've got a great testing team because they just show us that our product is broken. And they did it once, twice, 3 times, 500 times. That's a great tester. This tester keeps breaking our product every day. It's an amazing tester. And this is a lousy tester who's just sitting there and just checking boxes and saying, yes, it works. Yes, it works. We have to fire that guy or the girl. So this is the mindset. But these check boxes, they tell testers that we expect from you clean clean list of bugs. We don't want any bugs from you. We want green marks on all the lines. And that's what is wrong. So that's the first lesson probably learned today. Well, I'm trying to teach today is that, first of all, the bugs is a good thing, that we have to welcome them, and we have to motivate our testers to find them. And the second thing is that the process of this bug finding and bug reports finding, bug reporting, it has to be managed and organized. We need to think about, I don't know how exactly, it depends on your project, but you have to think about how you actually manage, how you actually organize the process of how do you buy bug reports. So you are, as a manager or as an architect, you are buying bug reports. So organize it. Make sure you're buying the right product. You're buying the high quality product. So you need to buy 500 bug reports the next month. So how are you going to do that? How can you be sure that they're high quality? You're buying them. You're paying for them. So you need them. You need to get them. So now the question is how you organize that. Think about that. I'm not giving explicit answers. I don't know how it's going to work in your case. What kind of bug tracking system you're using? How many testers you have? Do you outsource this work? Do you work it in-house? I don't know. But you need to think about how to organize the process of buying bug reports. That's it. Thank you for listening. See you next month, the first Wednesday of a month, 11 in the morning, Pacific time. Thank you, and bye-bye.